Great. So one watching. We'll start as soon as possible. Don't worry. Uh, just give me a minute. Great. So one watching. We'll start as soon as possible. Don't worry. Uh, just give me a minute. Okay. Cool. We'll start with the first question actually right now. Uh, mm, 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 mm. Code collab, interviews, work lives, course review. Great. So one watching career. We'll start as soon as possible. Don't worry. I made this. Just give me a minute. Just. Okay. Cool. We'll start with the first question actually right now. Uh, mm, 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 mm. Code collab, interviews, work lives, course review. Great. So one watching career. We'll start as soon as possible. Don't worry. I made this. Cool. Let's just start now. I've been delaying it a bit much. Okay. So what do we have here now? So our question first. Question one that we are doing today is it is binary tree vertical order traversal. So I have this data structure: time try 1, hint try 2, try 3. So I think this is pretty much clear. This is tree data structure. So here's the question. uh, Given the root of the binary tree, return the vertical order traversal of its nodes values, that is from top to bottom. Cool. We'll start with
Okay.
the
So
column
first
by
question
column. Let
actually
us say
right
they
now.
want 9,
Uh,
3 and 15 first, then 20, then 1.
mm,
4, 9. Okay, 0, 1 is actually at the same, so both should
lab
come.
introduce work life codes review.
Hmm.
Great.
So let's just
Watching
put this here.
career.
We'll start as soon as possible. Don't worry.
I mute this.
Okay. Cool. So I'm going to use
Just
code share here.
start now. I've been
Simply because
delaying
code
it,
share
but
helps me.
okay.
Okay.
So what do we have here now?
So what we have
So
here
our
is,
question
if we
first.
see is root
Question
3
one that we are doing today
9
is
20.
okay.
It is binary
7
tree vertical order traversal.
and
So I have this
15.
data structure. Time try
Okay,
1,
this is
hint
our
try 2, try 3. So code. I think
so what
this
we
is
have to
pretty much
see
clear. This
is,
is tree data structure.
let's just say assume this is
So here's
zeroth
the question.
place, and as we move in the right
Given the
side,
root of the binary tree,
this is first,
return the vertical order
we move this
traversal of
side,
its
this is the
nodes
second level. Now we
values,
move
that is
left here,
from top
15th,
to bottom.
ideally 15 should
Cool.
come here.
We'll start with
Okay.
the
So
column
first
by
question
column. Let
so
us say
this
they
is also
want
zeroth,
9,
and this is like
3 and
minus 1
15
level.
first, then
So
20,
because we are
then 1.
going left and right side
4,
here.
9. Okay,
Okay. So
0,
let's
1
just check the answer for this here
is
is 9,
actually at the same,
3,
so
15.
both
So the
should come.
order if you see here is
Uh,
okay. So order is
so let's just put this here.
9
We'll start as soon as possible.
from
Don't
top
worry.
to
I
bottom.
mute this.
So we were
Okay.
putting the top to
Cool.
bottom first,
So I'm going to
then
use code share
20,
here.
start now, and then 7.
Simply because
Delaying
code
it,
share
okay, helps me.
okay.
Let's just try the
Okay. So
second
what do we have
example
here now?
also. What we have here
Our
is
question
okay,
first
C is root
question
3,
one that
9,
we are doing today
9, 8,
is
7,
20. It is
1,
binary
7,
tree vertical order traversal.
0,
So I have this
15,
data structure.
4.
Time try
Okay,
1,
this is
hint
our
try 2,
solution here
try 3.
is 4,
So code. So what
9,
we
you
have
have
to
to
see
see
is, this
is
is tree
3,
data
0,
structure.
let's just say
1.
assume this is
So
0,
here's the question.
8 and 7 place, and as we move in the right
Given the
side,
root
so
of
if
the
we
binary
see
tree,
this
how
is
we have
first
decided
return
this
the
vertical order
solution, move this
traversal of
side,
its
this is the
nodes.
second level, we will come to the conclusion that okay, so now let's see, so we are at 0th level here, 0th level here. Now in this 0th level, this is minus 1, this is now minus 2, this is plus 1, and this is plus 2. Okay, now if we see here again, what I feel is that so as we move right side, we have plus 1, so this is very clear. As we move right side, we do plus plus plus, we'll move left, we do minus minus. So when we move from here from 8 to 1, again it was minus 1. But if you see the order here, 4, 9, so we see 3, 0 and 1. So even though it has a 0th level, for at each level it starts from top, left and right. This is the main point which I see in this case here. Okay, and see, we start with minus 1 also, so we starting with the leftmost numbers here also. So how should our code look like? Okay, so let's just assume some tree structure given in some solution here. I have done this code last time, but now I'm trying to do it all again, because I need to make sure that I remember all the solutions, because 45 minutes, two questions is not that easy to do. Okay, voice is quite low. Is it good enough now? Is it good enough now? Okay, wait. Uh, uh, is it good enough? Good enough now. Okay. Now let's try to start writing the code here actually first. Mm, nice. So we have this tree node structure here, and what we have already found that we need to start from the left side. So let's try to write the code now, or let's just decide the algo first. Exactly what format would the algo should be. Okay. So for our algo, it's this is like a pre-order thing, right? We go left, we go right, then we go left, we go root. No, 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 no. 301. This is not pre-order here. I think the main point is that we print the left first here. Okay, so let's just try to write the solution here. Okay, class solution, function name is public list vertical order. Let's just reset this. Okay, so this is our code path which is already given to us. Okay, now how do we do this? Okay. Mm, hmm. Okay, I may need to think about it a little. Okay. Uh, to we need a list of integers here. That is very clear. And we have a tree node here. So how do we do this? Whew. Okay. So let's just say if I think the basic thing is to just write the base case, like if root is equal to null, let's just create this array list of integers as vertical order list is equal to new array list uh, return vertical order list. It is null. Now if it is not not null, then what we do is uh, we eventually have to update this list. And how do we update this list? First we update this list by adding from the left side. Okay, so let's just if root dot left is not equal to null. Okay, what we need is a uh, we need a Okay, let's just try to like this. Okay, uh, print vertical order. Let's just have a different function. Public void, and let's just keep this outside. Okay, void um, parse in vertical order. So first would be tree node, and then index. So vertical order node comma 0. Okay, so now if node dot left is not equal to null, then we go this parse vertical order node dot left comma index is 0. Now index is index minus 1. Similarly, uh, if node dot right is not equal to null, parse vertical order node dot right index plus 1. Okay, so as soon as we meet a particular node with a particular index, let us say we meet a 0 node here. Okay, so let's see if we can keep a hash map of integer to nodes list, and then we can reverse it actually, because see what will happen is that, okay, no, we don't need to reverse it, because if you see the order here is we start from 3. Okay, so in 0th level. Yeah, so what will happen, 0 will, because we are going left for the first actually, and then going right, so it will automatically, this 0 would be opted first, and then 1 would be coming in later. Okay, what we need to do is just in order of list actually here. Okay, so let's just do this. Okay, if vertical order dot get 0 is equal to null dot get 0, because it's not get 0, get index is equal to null, then vertical order dot add index comma new array list. Okay, wait, now the problem is that we do not have a index left or right side actually. Initially we cannot decide what is the index actually is, because we have this 0 -1 -2, and if we want to decide the right number, it will have to be a little bit difficult here. So let's just build a hash map first here. Okay, so let's just keep a hash map of integer comma list of integers, uh, hash map list hash map list, and then this hash map list is equal to instead of doing hash map, we can just write map here. new hash map. Okay, now we have this here, hash map dot get. So now we have this, if hash map dot get index get key is get is equal to null is hash map dot put index comma new array list. Cool. And now we will just do is hash map dot put index comma uh, hash map dot get index dot list dot add node dot val. Okay, node dot value we added here. Okay, now what we have here is okay. Now what we have here is we added node dot val here. So we have what we have is our hash map uh, is it has the index here, and the hash map list also get index, so it gets the array list and adds the item in the list. So as soon as it parse now, so first item would be root, so root would be put in the 0th index here. And then as we go from the left side, because we go to the left side first and we are checking if we don't go it, okay, then it will again just, so 9 will then the 9 will come from this side. Now as we have already gone to this order 9, so now we'll again go to the parse vertical order. Hash of this, the index would be -1 this time, and then hash map dot put will be index -1 and then URL list, because it has no -1 has not been initialized till now. And then the 9 would get put here inside, so and then the 4 would also be put here inside, and then we go right side after it. So now 0 will be put in the same index, because we have index plus 1, so -1 plus 1 is 0. So 0 would be put first, and then 1 would be put later here. People who are watching, let me know if any explanation. Watching watching let me know if any explanation is not good enough, and need, and I should re again tell. Okay, so I think we have done a good job here. The only thing now left is, after this is call is made here, the whole code will come, this will complete it, because eventually it will go to the right of root also, and then again, so our hash map would be built. The only thing left at this point of time is build the list from the hash map here. Okay. One thing we can do, instead of making it a hash map here, we can actually keep it as a set also, because if I keep it a hash set, no, hash map is good enough here. Okay, so one thing we need to do is keep a minimum value here. Let's just say int minimum index is equal to 0, and what we will do here is, because okay, if there is, if it will only come in this job if it is not null now, because we have to check this. So one thing we'll do here, or instead of doing it here, we'll just do it here now in the first time it is initialized. uh, if min index if min index is greater than index min index is equal to index. Okay, now we have this min index already here, and we know that, and let's just keep a max index also here, int max index also. This will make my work a little bit easy. If max index is less than index, then max index is equal to index. So I have the min index and max index also calculated here. So now I simply need to do here is just for loop for int I equal to 0, sorry, int I is equal to uh, what do I call it, uh, I equal to 0, I less than uh, absolute of min index and max index. I don't know. How would it be? So okay, let's just do this. For int I equal to 0, I equal to min index, I less than equal to max index, I plus plus. Okay, and then we have this int j equal to 0, 0, and what we'll do is uh, vertical order list dot add j comma our hash map list get dot get is now min index, no sorry, I dot get I. Yeah, so now we have this add of this list here. We have already done this now, and this will, and then we'll just return the vertical order list. Okay, the code seems to me to be is complete. We have written code in the same meta format, where we will be only allowed, we are not allowed any type of code sharing or like auto code completion. Now we are also not even actually allowed to push the code, run the code, but we will try to do this for ourselves, simply because to know that we are right or not actually. So now let's just take the whole code here from here, and let's just put it here now. uh, let's just try to run the code. Okay, sorry, see, at least some basic errors we still get. Let me see what I did wrong. Okay, node cannot find symbol. Okay, sorry. See, if you see the type of mistakes we do now when we write code without. Okay, and not find symbol, vertical order list of vertical order list. Sorry, what was the test results? Order list cannot find symbol, vertical order list. We have this vertical order list now here. What happened? Vertical order list. Oh, see, again errors here. There's some errors we keep on making. Actually, I had to call this function. Okay, boolean cannot be converted to the list integer. Boolean, why the fuck would it be boolean? We have this hash map of integer list of integer, hash of list put integer get index, not add node dot val. Node dot val is not boolean, integer. Now get, so that get will give me new array list dot get index. I don't know, bro. Dot put index hash dot get index dot add node dot val. We have this node dot val here. Okay, can anybody help me with the error here? What's happening? What is the issue with my error? Can anybody help? put index here. Okay, now dot get index key. When I say hash map dot get, I get this index. Okay, and then I do this add. I got the list. In the list I can do add now. What is the error here? Boolean cannot be converted to list integer. Hash map list. Hash map list. Map of integer to list of integer. ठीक है, equal to new hash map. Okay, if dot get is equal to null, it contains dot get, it contains key. Now dot contains key not. Key not. Okay, at this point of time I'm not sure what exactly am I doing wrong here, so I'm going to go to my IntelliJ here. LeetCode trees and graphs. So let's just say okay, see I have this code here. See, let me just start a new code here. Java class vertical or